morning everyone. Today we are going to continue the lesson of the mass and weight. We are going to take some rules to show if I have, for example, if I know my mass, can I calculate the weight without using a spring balance? For example, if I know my mass is 40 kilograms, can I calculate my weight? Or do I will hang myself down on the spring balance to know my weight? No. I can know my weight without using the spring balance. How? Scientists find that if I have an object whose weight is 1 kilogram, its weight is going to be 10 Newton. And if I have an object whose mass is 2 kilograms, the weight is going to be 20 Newton. If I have an object whose mass is 3 kilograms, then the weight is going to be 30 Newton. From this, I can calculate, I can know my weight from rule number 1 is that the weight is equal to mass in kilograms times 10. And I mean the mass in kilograms. If I have the mass in grams, then I have to change it to kilogram. So if I have any object, I have the weight, the mass of any object, and I want to calculate its weight, I can calculate it from this rule. Let's do it in a different way. I will do this triangle like this, and I will write here weight, mass, and 10, so that I will not forget the rule. If I want to calculate the weight, I will do like this, so it is mass times 10. For example, if I have a mass of an object, so the mass of an object is 10 kilograms, and I want to calculate the weight. So the weight is going to be, the mass is 10 times 10, so the weight is going to be 100 Newton. Right, if I have the weight, can I calculate the mass? Yes, of course. How? I have the weight. I want to calculate the mass, so I will do like this. So the mass is going to be weight divided by 10. The weight divided by 10. So this is rule number 2. The mass is equal to the weight divided by 10. Okay? Here I have 2 problems. I'm going to try to solve them. Number 1, calculate the weight of an object whose mass is 6 kilograms. So I'm going here to use rule number 1 or rule number 2. I have calculate the weight. So I'm going to cover the weight. So the weight is going to be mass times 10. Number 1, I have to write the rule. So the weight is equal to mass times 10. My mass here is 6. 6 what? I have to be careful. It is kilograms or grams. Okay? If it is grams, I have to convert it to kilograms. So here it is kilograms. So I will write 6 times 10 is equal to 60 Newton, because I am calculating the weight. So the unit is going to be Newton. Another example, if the weight of an object is 20 Newton, calculate its mass. Here I have the weight, I want to know the mass. I will cover the mass, so the rule will be weight divided by 10. So the mass is equal to weight divided by 10. And again, I have to write the rule. So it is going to be 20 divided by 10. So 2 mass, so it is going to be kilogram. Clear? If I have the weight of an object on the Earth's surface, can I calculate the weight of the same object on the moon? Yes. The weight of an object on the Earth's surface differs from the weight of the same object if it is going to be on the moon. Why or how? Because we said in the factors affecting the weight that one of the factors that the planet on which the object exists. What is the meaning of this? For example, if I have, this is the Earth and this is the moon. As the size of the planet increases, the weight will also increases. As the size increases, the weight will also increase. So the weight of any object on the Earth's surface is going to be bigger than the weight of the same object if it is going to be on the moon. Why? Because the size of the Earth is bigger than the size of the moon. So the weight on Earth is going to be bigger than the weight on the moon. So again, the weight of an object on the Earth is bigger than the weight of an object on the moon. Why? Because the Earth is bigger than the moon. So here we have more gravity, so more weight. Here on the moon we have less gravity and less weight. But the Earth is bigger by the moon by how many times? By 6 times. The Earth is bigger than the moon by 6 times. So if I have an object on the Earth, the weight of this object will be 6 times bigger if the same object was on the moon. Again, if I have an object here, for example, my weight, I'm on Earth, my weight will be 6 times my weight if I'm going to go to the moon. Why? Because the Earth is bigger than the moon. Why especially 6? Because the Earth is bigger by the moon by 6 times. So if I want the moon to be in the size of the Earth, I will have to put 6 moons together to get the same size of the Earth. If the size of the Earth is 6 times the size of the moon, what about the size of the moon? The size of the moon is going to be 1/6 the size of the Earth. If I have, this is the Earth, I will divide it to 6 times. This is the moon. So the moon is going to be 1 out of 1, 2, 3, 4, 5, 6. So it is going to be 1/6 the size of the Earth. So if I am going, so what is the rule, my rule for this? Rule number 3. Weight on Earth is going to be equal to the weight on the moon times 6. While rule number 4, the weight on the moon is equal to the weight on Earth divided by 6. So if I have an object on the Earth, this is big. I want to know the weight on the moon. So I'm moving from big to small. I'm going to make divided by 6. While if I'm on the moon, I want the weight to big, it is times 6. Again, from big to small, divide. From small to big, times 6. We are going to solve some problems to see how we are going to